I'm going to begin with a very sort of simple question. What is a reference frame? And that's my punchline. And here's why I want to know. There are actually fundamental differences between classical and quantum frames. And I've been working on this stuff for the last few years. And one of the most striking examples comes in the form of a super selection rule. And I should just mention, if you're interested in any of this stuff, I just put up some links. Otherwise, this is all you get slide-wise. So what super selection rules are, if you don't know, are postulated. They're like axiomatic restrictions on the type of quantum states that can be prepared and the types of quantum operations that can be performed. And it's been shown that super selection rules are equivalent to the absence of a classical reference frame for some particular degree of freedom. So quantum reference frames, by contrast, can actually be used to circumvent the restrictions that super selection rules impose. And this is a whole field called quantum frameness theory within quantum information that I've written. Some of those papers are sort of on standard stuff. And this difference bugs the hell out of me. Why is there this difference? Could we develop a more general theory that explains this difference between quantum and classical reference frames, in particular the super selection rule? And what could that tell us about the role of the observer? And within that, there are several questions that I'm interested in pursuing. The first is there are different definitions of what a reference frame is, regardless of classical or quantum. There's the Machian view of you need an aggregate of particles, and it can be but nevertheless it can be an abstract point in space, versus in some quantum versions, it has to be a physical thing. It's got to actually be a particle of some sort. What could this tell us about that difference, and maybe we can reconcile that difference? Or could it be that maybe super selection rules are just a rough guide? They're just axiomatic. Maybe they're not even that important. Maybe we're just making things more difficult than they need to be. Also, since the introduction of reference frames necessarily breaks some inherent symmetry in the universe, what could a broader understanding of reference frames tell us about broken symmetries that we see in the universe? And I'm sure you could come up with a million different examples of that. But the other interesting thing that I'm interested in here is that given that both super selection rules and Cauchy-Becker type contextuality define restrictions on quantum states, maybe there's a link between the two. My hunch says yes. I'm sure some people's hunch says no. There's no link between the two. But my hunch says there is a relationship. And what is it? Now, I just mentioned, so that's the basic gist of what I'm interested in. So reference frames sort of take over my life lately. In somewhat related work, I'm also exploring in conjunction with Andrzej Dragan. Some of you may know Andrzej at the University of Warsaw, and a few others who are sort of coming in as we're doing this. Issues based on the following super simple thought experiment. So just as an example, this is one example, you can come up with other ones. If you imagine a neutral pion that decays to a couple of photons, and you put it in an optical cavity where the optical cavity won't allow those photons to exist, the pion won't decay. This is called frustrated spontaneous emission, or inhibited spontaneous emission, I think is the term that's actually used. So, but what happens if you take a cavity like that and you accelerate it, right? So if you accelerate it, you can get some, the length will change. You accelerate it to relativistic speeds. And so I want to know why. So it can then suddenly it can now decay, so it suddenly makes it okay to decay. And I want to know why that is. And because in other words, that means reference frames have some real ontological basis. So anyway, last thing I'm going to say is I need money. So if any of your funders are out there, I don't need a lot, just enough to visit my collaborators who are in Europe. So